Today we're diving into a paper that explores a new approach to enhancing large language model reasoning. Iteration of thought, leveraging inner dialogue for autonomous large language model reasoning, proposes a framework called IoT, which aims to improve LLM responses through iterative prompting. What's the core idea behind this framework?
The core idea is to mimic the way humans interact with LLMs. We often ask a question, receive an initial response, and then provide further guidance or feedback to refine the answer. IoT tries to automate this process by introducing an inner dialogue agent, IDA, that generates prompts based on the initial query and the LLM's previous responses.
So instead of relying on static prompts, IoT dynamically adjusts the reasoning path based on the evolving context. Can you elaborate on how the IDA works?
The IDA acts as a guide, analyzing the LLM's response and identifying areas where further prompting could be beneficial. It then generates a new prompt that encourages the LLM to explore specific aspects of the problem or consider additional information. This iterative process continues until the LLM reaches a satisfactory answer or a predefined number of iterations is reached.
This sounds like a more flexible approach compared to existing methods like chain of thought, COAT, or tree of thoughts, TOT. What are the key differences?
COAT and TOT rely on static or semi-static prompts, which may not adapt well to the evolving context of each query. COAT encourages the LLM to articulate its reasoning steps, while TOT explores multiple reasoning paths in parallel. IoT, on the other hand, dynamically adjusts the reasoning path based on the LLM's responses, allowing for more adaptive and context-aware reasoning.
The paper presents two variants of IoT, autonomous iteration of thought, AIoT, and guided iteration of thought, GIoT. What are the differences between these two?
AIoT allows the LLM to decide when it has reached a satisfactory answer, while GIoT forces a fixed number of iterations. AIoT aims for efficiency by minimizing unnecessary iterations, while GIoT prioritizes thorough exploration of the reasoning space.
The paper evaluates IoT on various datasets, including GBQA, Game of 24, mini crosswords, and Hotpot QA. What are the key findings from these experiments?
The results show that IoT outperforms both COT and the baseline input-output I/O approach on most tasks. AIoT demonstrates significant improvements on GPQA, a dataset that requires deep reasoning and comprehensive knowledge. GIoT performs well on tasks that benefit from exploring multiple reasoning paths, such as Game of 24 and mini crosswords.
It seems that AIoT is more effective for tasks that require a more focused approach, while GIoT is better suited for tasks that benefit from broader exploration. Is that a fair assessment?
Yes, that's a good way to summarize it. AIoT is more efficient, but it can sometimes prematurely converge on an incorrect answer. GIoT, on the other hand, is more thorough, but can be computationally expensive. The choice between the two variants depends on the specific task and the desired balance between efficiency and thoroughness.
The paper also compares IoT to the agent-light framework on the Hotpot QA hard data set. What are the key takeaways from this comparison?
The comparison shows that AIoT outperforms agent-light, achieving higher F1 and exact match scores. This suggests that IoT's dynamic reasoning capabilities are particularly beneficial for multi-hop question-answering tasks, where the model needs to integrate information from multiple sources.
So IoT seems to be a promising approach for enhancing LLM reasoning. What are some of the potential benefits and limitations of this framework?
One of the key benefits of IoT is its explainability. The sequence of prompts and responses generated by the IDA provides a clear trace of the LLM's reasoning process, making it easier to understand how the model arrived at its answer. This can be particularly useful for debugging and improving the model's performance.
That's a significant advantage. What about the limitations?
One limitation is that AI IoT can sometimes misjudge the completeness of its responses, leading to premature convergence. This could be addressed by incorporating feedback mechanisms or allowing for human intervention. Another limitation is that GIoT can be computationally expensive, especially for complex tasks.
The paper mentions that IoT could be combined with other reasoning methods, such as COT. What are the potential benefits of such a hybrid approach?
Combining IoT with COT could potentially amplify the benefits of structured reasoning while retaining the flexibility of iterative refinement. This could lead to even more powerful reasoning capabilities.
The paper also suggests that the IDO could be expanded into a meta-agent consisting of specialized sub-agents. How could this further enhance IoT's capabilities?
A meta agent with specialized sub-agents could potentially handle more complex tasks by dividing the reasoning process into smaller, more manageable steps. This could lead to more efficient and accurate reasoning, but it would also introduce additional complexity and computational overhead.
To wrap up, can you summarize the key contributions of this paper?
The paper introduces the iteration of thought, IoT framework, a novel approach to enhancing LLM reasoning through iterative prompting. IoT outperforms existing methods on various tasks, demonstrating its potential for improving LLM performance. The paper also explores the benefits and limitations of IoT, highlighting its explainability and potential for future development.
This was a fascinating discussion on the iteration of thought framework. Thank you for sharing your insights.